All right, we're going to go ahead and take a look at the CFA from 6.6, 6.5, 6.6, and 6.7. Make sure you've got your study guide here and you're filling out as we go along here, and we'll kind of reteach and go through our thoughts here a little bit. Okay, so we're going to find the value of the missing number that will balance these pans. Okay, so we've got to keep everything balanced. So the first thing I see here, there's a couple different ways we could do this. I actually wrote in one more pan balance because we're going to need it here. Okay, so you can draw that in if you want to as well. But I see I've got x's on both sides and I've got numbers on both sides. And again, I'm trying to get x down to 1x and what that equals. So I got to start pulling stuff off both sides to keep it even. So I could, let's look at the numbers here. Okay, if I have this one here, I could take away this 37 here. I'm going to take that off. So if we're thinking of pounds, we're taking 37 pounds off there. So I also have to take 37 pounds off of this side. So 46 minus 37 is 9. So I'm left with 9 pounds here. But I still have 1x, and I don't have to put 1x. I can just put x. Same thing there. It's still left on this side. Okay, and here I have 4x's yet. I just got rid of 37 pounds. So I'm thinking about that. I just went over here and I subtracted 37 from both sides. And that leaves me with this. Okay, now we know we want those x's. We don't want to leave them on separate sides. We want to get them onto the same side. So let's pull off this x. Okay, so if I pull off this x and take that off, I also have to pull off an x off of this side. Okay, so I take the same amount off each. So I'm left with 3 x's over here and 9 over here. And now I've got it into a place where I can easily solve it. I'm thinking 3 times what equals 9. Okay, and I know x has to equal 3 there. I'm doing my little trial and error method there, and I know 3 times 3 is 9. All right, so we know we need to go back and plug these in to make sure I'm right and didn't do something wrong. So I'm going to erase a little bit here, and let's go plug it in and double check. Okay, if we say x is 3, we'll do our PEMDAS here. 4 times 3 is 12. And then I know 37 plus 12 is 49. And this is 46 plus 1x. We know x is 3, so this is just 3. And 46 plus 3 is 49. So they do equal each other. So I know in this case, x has to equal 3. And again, I know I'm right because if when I plug it in and it works, I know that that's what x has to be in order to make these two sides equal. Okay, over here we don't have any variables. We could have it an x here if we'd like to. But I'm just going to kind of use my logic to go through this. I'm just going to go ahead and 80 minus 10. I'm going to change that. I know that's 70. So really, this is pretty basic. I'm just thinking this side equals 70, so this side has to. So 36 plus what gets to 70. So I could subtract 70 minus 36. And if I do that, I'll get 34. And then 36 plus 34, I can double check. Yep, that's definitely 70. So down here, we can just write, the open blank has to equal 34. They just use the open blank. It's kind of confusing there. That could have been a variable. So that open blank has to equal 34. And a lot of times we'll have that a variable like x. It's just our unknown. Okay. Gonna make sure you've got this copy here. We'll scroll down and take a look at the last couple of problems here. So pause the video if you need to. All right, so on number 2 now, we're going to simplify using the distributive property, and we talked about combining like terms so we make them easier to solve here. So I'm going to have to distribute through, so 3 times x. Again, I like to draw my little lines there to help me remember to distribute. So 3 times x is 3x, plus 3 times 4 is 12, plus 3 times x is 3x, minus, because it's a minus in here, I'm distributing, I got to take the 3 times the 3, so that is 9. A lot of people forget to kind of distribute through the second number in those parentheses sometimes. Okay, that stuff we did when we were studying distributive property. The new stuff now is to combine these like terms. All right, so we got to get x's with x's. So this is 3x plus 3 more x's. I have 6 x's now. So they're both positive. I like to cross them out and stay organized. And then I've got numbers can combine with numbers. So this is just 12 minus 9, which is a positive 3. So this is 6x plus that 3 more, because 12 minus 9 is 3. And that's combining everything there that I can combine. I can't combine the 6x with the 3 because they're not like terms. All right, only numbers can be combined with numbers, and x's combined with x's in this case. Okay, one more time, let's distribute. 7 times p is 7p, plus 7 times 2 is 14, plus 2 times p is 2p, minus, and this is 2 times 5, draw my lines there, which is 10. Really similar problem to what our last one was, so let's look to combine things. 7p plus 2p gives me 9 of those p's. And then I've got a positive 14, or 14 take away 10 is a positive 4. So we've still got plus 4 in there, and we've combined all the like terms there. Again, both problems are really similar, but we're going to have to distribute a lot before we can combine like terms, so that's something we want to be really good at and efficient with. Okay? All right, so I'll erase these and scroll up a little bit more to finish the last one. Again, pause the video if you need to. In the last one here, we're going to circle the expressions that are equivalent to what they have here. All right, so they give us several options, and we got to see which ones are equivalent. So let's get her out of the light here to make this a little bit easier. Bad spot there. Okay. All right, so we've got this, and I think the easiest thing is to go ahead and to distribute first, and let's just write it out before we start looking at the options here. Okay, 3 times n is 3n, plus 3 times 3 is 9. Again, distributing, just like we did above, plus 3 times n, minus 3 times 2 is 6. Okay, so this is actually pretty similar to one we did above. We just have a different variable. All right, so if I look down at my choices here, I've got 3n plus 3. And I see what they did here is they forgot to take the 3 times the 3. They just said 3 times n and then added 3. So this is wrong. And they did the same thing over here. 3 times n and then minus 2. It should be minus 6, right? So I can eliminate that. They forgot to distribute through the second part of the parentheses. If I combine like terms here, I have 3n and 3n, which is 6n. And then 9 minus 6 is a positive 3. So this one definitely works. That's the best form actually right there. Okay, so 6n plus 3 works. This one is 3n plus 6. 3n and 3n, that's 6n. But this is 6 minus 5. So it looks like when they multiplied to distribute, they thought 3 times 2 was possibly 5 or added them. So this one, they made a mistake there. That doesn't work. And this is 3n plus 9 plus 3n minus 6. And that's exactly what it is when I first distribute it through. They just hadn't combined like terms yet. So this is definitely correct too, because it's the same as what I do when I distribute it through. Okay. Then I combine like terms. This actually gets to be the simplest form and way to look at it. Okay. So again, make sure you've got these written. You're going to do a lot of combining like terms when we're solving. So we're continuing to work on that.